Hello and welcome once again to a new episode. In this video, we are continuing our discussion on data organization, then data preprocessing. And we are going to continue from where we left off in the last video. We got to the point where we've been able to identify which features forms our input and then which feature forms our output. Now, if you observe our training data sets on the board right now, you can see that CS101 is not numeric, and neural networks deals with numbers, nothing more. This, however, doesn't mean we cannot use other forms of data to train a neural network. The problem then becomes, how do you map your non-numeric data into something that is numeric so that the neural network will be able to use it? I'm going to mention once again that at the core of a neural network is what is known as the weights and biases, or the parameters, which you will understand perfectly once we start coding. And I want you to remember that the knowledge base, or the patterns that a neural network learns, is represented internally as nothing but a big matrix of numbers. That is all. So, there is no way we can send CS101 into a neural network, because internally what happens is a lot of matrix multiplications. And there is no way we are going to be able to multiply some number by CS101. So, this is the pre-processing stage, which is very crucial when it comes to getting correct machine learning models. If you joke with your data pre-processing stage, remember that I said neural networks are more about the quality of the training data than they are about the algorithms themselves. So, the better your training data, the higher your chances of succeeding with training a neural network that has a high accuracy that surpasses human performance, which is what we seek in the field of AI. So, we need to make sure that the data we are sending into our neural network is in the correct format that the neural network can use to learn. In this particular case, it is simple to cure this anomaly in the data set. You can see that, yes, CS101, CS102, CS211, CS, these are tests, but then we can just have a dictionary or a lookup table where we say, okay, CS101 is going to be represented as 1, CS211 is going to be represented as 2, and all other courses will also have their corresponding representation in the dictionary. So, what is going to happen is we come up with a lookup table where we say, okay, for CS101, we represent it with the number 1. For CS211, we represent it with a number 2. You can even start from 0, it doesn't matter. So what is going to happen is you come in here, and wherever you see CS101, you put 1 there. You put 1 there. You put 2. And you put 2. And now our data set lends itself more for correctly training neural networks. This is a very simple way. There are many ways of curing your data before sending them through a neural network for training. But this is one simple way to ensure that everything that goes in there is numeric. So, you have learned how to get textual information to be represented as numbers in your training data set. And We started from knowing how to lay out our data in the first place, asking ourselves some important questions like, what problem are we trying to solve? What data is needed? What features are needed to answer the question that we want the neural network to be able to answer? What is the expected output? What do we want the neural network to be able to come out and tell us? And that becomes the output. Every other feature set in your training data set becomes part of the input that you feed into your neural network. Once you've done that, you go through and then you ensure that everything in there is numeric. If it is not numeric, a simple lookup table like what I showed you in this video should be enough to cure that. There are better approaches, but for starters, a simple lookup table like this should work. So thank you very much for watching, and I want to encourage you, if there are any things you don't understand, leave a comment and then I will get back to you. So thank you once again, and I will see you in the next video.